Welcome to Part 8 of Competency 15. In this video, we will work with linear transformations of data, and again, on the TI-84 calculator. Okay, it says use the following data set to solve the next 6 questions. And here is our data set, and it tells us what the mean and variance and standard deviation is. And by linear transformation, they mean we're following this format, linear format. Okay, it looks a little different than what we're used to. That's okay. So, in this, for us, for our purposes, yes, this has to do linear transformation with how the data looks. It has a lot to do with that. But we're going to focus on the use of our calculator. Okay, so we push stat and we enter because it's highlighted on edit. That gives us our list. In L1, we have already entered what we need. There's our data set entered for us. However, it says in number 1, if each number is increased by 3, that means plus, how does this affect the value of the mean? Okay, so what we need to do is arrow over, highlight L2. And we can actually, instead of like doing that for each number, don't do that because you might make mistakes. Okay, what are we going to do? We're going to say we want L1, that second one, and we're going to add 3. Push enter, and it populates exactly what you need. Now we need to determine the mean. And if you go ahead and look at number 2, they're asking for the same thing, except how does that change your variance? How does that change your standard deviation? Okay, so we're going to back out, go to stat, go over to calc, and we want, again, we've done videos on this, or including it. We want the one var stat, and it's already highlighted, so push enter. But we are interested, we can check L1 first and see what that gives us. Let's do that. Let's go second, L1, push enter. No frequency list, push enter until you get what you want. There it is. Notice that we are verifying our standard deviation and our mean. Our mean is 10 and remember the standard deviation, it is actually SX because it's a sample. When you see these notations being used as their equivalent, they might be, they may not be. In this situation, they're using them interchangeably. Okay, we're going to go with what they have. So, let's go back. Let's enter out. Let's go stat. Let's go over. Let's go again. But this time we want second 2 for L2. Keep entering. And then what do you get? Look at our mean. Now our mean is X bar. That's another thing. You need to know. Oh my gosh. Let's see if I can do a better job here. You need to know that they're going to use X bar. You're going to see this in your classwork, your textbooks. So we need to know the difference, okay? So we're looking for X bar. Well, it increases by 3. Just add 3, okay? And that would be option C. Now, we're going to go straight to number 2 and see what happens with our number 2. Let's see here. Okay. Let's see if this thing will let me go up. We'll go up just a little here so we can see. Oops. Okay, so what happens? Well, we see that we have our sample X, which is 5.18. Okay, so we can say, hey, this is all right. We get rid of the first 2. So that leaves us C and D. All right, now we could just square that, or you can estimate it. 5 times 5 is 25. So it's going to be than uh, greater than 25. So that leaves us D. So maybe we aren't doing, or we're not going with option C, okay? All right, so how do we know that for sure? Okay, so we can push vars, number 5, and arrow down to 3, or just push 3, whichever. push enter, then push x squared, enter again, and it is verified that our option is D. Okay, now we're going to go to number 3, and it says multiply by 4. So go to stat, okay, push enter because we want to go back to our list. We're going to do the same thing by arrowing over, highlighting. Okay, let's make a note. We are in L3. These were in L2. So what are we going to do? Again, but we're multiplying, not just adding. So we're going to say second L1 times 4. We're going to do exactly what the question says. Push enter. Okay, now that has populated our list for us. So what do? We go to stat, arrow over, push enter, and we are in L3. So second L3, enter until we get what we want. Okay, that means the mean increases to 40. And remember, mean, mu, notice all those mu's. Mu's is a notation for mean, okay? All right, so that gives us that. Now let's see what number 4 has to ask. Okay, for number 4, it says, how does this affect the value of the variance and the standard deviation? Well, we can see that we have a standard deviation right here. Remember, we're looking for SX, the sample standard deviation. That's our sample standard deviation, and it is 20.71 rounded, so that gets rid of B and C. That leaves us A and D. So what do? We say vars 5, go to number 3, push enter, square that. That's the x squared button. Push enter, and that gives us 428.8, and that would mean that D is out, and we are using option A. Okay, now let's look at number 5. 5 and 6 go together, actually. It says, if each number is multiplied by a half and subtracted by 8, how does this affect the mean? And 6 is the same thing, except how does this affect the variance and standard deviation? Same process as before. So we need to push stat, enter, because we want our list, and then go over, and we're going to do the same thing as we did before. Highlight your L4, and we need second one, and we're saying let's take the first list. Yeah, and I think with order of operation we'll be okay. We can multiply it times 0.5, which is easiest, and then subtract the 8, and that's what it says to do. Now we need to enter, and that looks really good. That's what it gives us. And let's push stat, over to calc, 1, and now we want L4. Second, 4, enter everything. We don't want that list. Okay, so now from this, we have a mean of -3, which is very possible. We're turning this into a negative mean. So the only one that's possible that the only option is C. Okay. Then we look at our sample deviation, standard deviation, and that is 2.59 rounded. So that eliminates C and D. Okay, now we need to go between the two. Let's think about this. Well, 2 times 2 is 4. Well, it could be 5. Okay, 4, 5 and 6 are greater than. Okay, let's not try to do it in our head, but we can't just eliminate A and B real fast. I can already see that. So let's go vars 5, go down to your 3, enter, square that, enter again, and it's A, 6.7, and we don't have to round. Okay, great. Number 7, the mean of a group of individual data is 16 and the variance is 5. A new group of data is formed by multiplying each number by 3 and subtracting 11. What are the mean and variance of the new group? Okay, if you didn't understand what we did in prior problems, the process we followed to get our answers, you might want to rewind the video and take another look. Okay, but we're going to write that right here and show you. We start with a mean of 16. This implies that we follow exactly what it says. The mean is affected directly, so that means we take 16 times the 3 minus the 11, and this will equal a mean of 37, which we have with A and D. This eliminates C and B. So 16 times the 3 minus the 11, yes, gives us 37. Okay, now we need to show how do we get our new variance? Okay, well, we're going to look at the standard deviation. So the variance, we're going to say that not standard, the given variance, excuse me, and then we'll talk about the standard deviation. Okay, so this equals 5. Okay, and this implies for our new value that we take 5 times, now this is what I need you to see, the 3. Only the multiplying directly affects the variance, okay? So that is going to be 3 squared. Why? Because our variance is squared, okay? So that's going to be 5 times 9 is equal to 45. Now, that gets us our answer of A, which is great. But let's analyze where that came from. Let's go backwards and kind of make a connection here. Okay, so if we want to take that variance and get our standard deviation, we just take the square root of that. Well, if we take that and we multiply that, again, we're looking at the 3, okay? Notice a pattern happening here. We will take that 3, only the 3 directly affects, okay? So really what we're doing is we're taking this entire new variance, and we put it under the square root, okay? So let's see, let's go backwards. So we have 3 square roots of 5. That actually equals 6.07. Okay. So what happens? Think about that. So what we really had, we underneath the square root, if we have 9 times 5, which is what? The square root of 45. Well, this is actually, I'm going to pop up and show you. This is kind of like a play on numbers or trying to get you to see where all these numbers come from, how it works. Well, 6.07, if you go up, that's actually the variance of number 6, the prior value. So all of these are connected. So we needed to know how this works, okay? So we've made that numerical connection. Well, let's look at how this would actually work for us in a situation, a realistic situation. Okay, so let's look at number 8. A teacher wishes to curve the raw scores of an Algebra 2 course. The mean score of the class is the 66 and the variance is 4. If the teacher wishes to ensure that the average, this will be our new data, the average and the standard deviation of 4, what changes should be made to the score. Okay, this one's kind of tough to see. You kind of have to play with the numbers. But if you look at your answer choices, it gives you a hint and you know that there's some things that you shouldn't do. Okay. One thing is they're saying, let's look at A. The original mean is 66. The original mean should be multiplied by 2 squared and subtract 5. Okay, remember we're going from 66 up to 75. The actual difference of that is 9. Okay, and I think what they may be trying to do is trick you. Remember, we have to go by a process, and the process didn't involve squaring anything. But if we squared that, that would be 4. Okay, if we multiply by 4, let's see, 66 times 4 minus 5, what does that get us? Well, it doesn't get us 75. Remember, the mean you're going to go by the exact process. Well, they gave us the process. It doesn't work. Let's go to B. Uh, it's a little different. They say multiply by 4 and then subtract by 57. Okay, let's try that. Okay, 66 times 4, subtract 57. That's not going to work. I don't like that. Okay, let's try it again. Let's try the next one. Multiply by 2, subtract by 5. Okay, 66 times 2 minus 5. That's not going to work either. Okay, cross your fingers. This last one's got to be it. If it isn't, then, boy, I need to go back and look at what I was told you guys to do, right? Okay, 66 times the 2 minus 57. Let's see what happens. If I can push enter. It is. Oh, thank goodness. Okay, it's a possibility. At least the first line works. Okay, now let's look at what happens to the original variance of 4 will be multiplied by 2. 2 squared. Okay, so they're saying, and we need but we're looking for a new standard deviation. Okay, so that means we take our variance of 4 and 2 squared. 4 times 4 is 16. Okay, and that is equaling the variance. Okay, well, this implies that to get my variance, all I have to do is put 16 under a square root and we come out with a 4. And yes, D is our option. It checks. Okay. Oh, and by the way, this question, go back, think about it, because I've seen this on a practice test at a university. Okay, actually, in a couple of different places. So go back and give this another go. All right, make sure you understand all this because a question involving this is highly likely, especially at the university level. Okay, once again, if you want to keep us free and keep adding, could you subscribe to keep all this going? And don't forget to give us a like and a share. Happy testing!